basically says that the derivative, if it exists, of a function to a power. Now this looks very similar to our old favorite rule, x to a power. Just like the second rule, the bottom one says, you keep the x, you bring the power in front, you make the new power one less. The general power rule, which is the top line, instead of x, you have f of x. You keep it the same, you bring the power down, and then you make the new power one less. Then you multiply by the derivative of this, or if you prefer to look here, the same derivative of that, which is f prime of x. So the line below isn't going against this, because when we multiply by the derivative of that or the derivative of that, it's 1. And we do get nx to the n minus 1. Okay, if you have something more complicated than x, and you're raising it to the nth power, you have something a little bit complicated. More than x. X squared plus 1, x plus 1, x cubed plus 7x squared plus 9. And you're raising it to a power, and you're asked to find the derivative of that. Well, you keep the function the same, and you play games with the power. You bring the power down, you make the new power 1 less, times the derivative of that function. Okay, for example, if you were asked to find the derivative of 3x cubed minus 2x plus 14 to the third power. Okay, what I just underlined, that's the function, that's f of x. 3x cubed minus 2x plus 14. You play the power game. This 3 comes in front, the new power is 1 less, times the derivative of what's in here, which is not 6, sorry, 9x squared minus 2. 9x squared minus 2. There's your answer. If you can, you try to clean it up a little bit. For example, if there was something common between the 9 and the 2, which there isn't, but if there were, I factor it out and multiply by the 3. Let's try a couple more. Suppose I tell you that capital H of x is equal to 7x cubed minus 4x plus 1. Actually, 1 over that. And like I told you earlier, I promised you that you should not take the quotient rule. I showed you that you shouldn't take the quotient rule when the denominator is a constant. And I mentioned even when the numerator is a constant, don't use the quotient rule. Now let's make the top a little bit more complicated. It's 4. Now remember that this bottom is raised to the first power. So we'll just use a little algebra. We'll bring the bottom to the numerator, but then we change the sign of the power. And it should not be 1 or negative 2, but instead of 1, it becomes negative 1. In fact, if this were 11, I would put negative 11 up there. So now we're going to use the general power rule along with the constant rule. You have a constant times a function. So just like when you had 4x to the negative 1, the derivative of that, you multiply, you get negative 4, keep this the same, make the new power 1 less. You're going to play the same game. Multiply the negative 1 by the negative 4. That is, bring down the negative 1, keep the function the same, make the new power 1 less. And when I say bring down the negative 1, you multiply it by the constant in front. So there's the function. I brought down the negative 1. I made the new power 1 less. Times the derivative of what's in here. 21x squared minus 4. Okay, now we are multiplying three things. The negative 4, the 7x cubed minus 4x plus 1 to the negative 2, and 21x squared minus 4. If any one of these factors have a negative exponent, like the middle one does, since it's in the top, I'll move it to the bottom, and I'll make the power plus 2. But the negative 4 times the 21x squared minus 4 can stay. That stays. And there's your derivative. The numerator is a constant. Don't use the quotient rule. Just use some algebra. Bring the denominator up, and then use the power rule. The formal name is the general power rule. Most people abbreviate that and they call it the power rule. So, if you had, so now, there's no reason to do the following. If you have 7x minus 2 over 4x cubed minus 1, people are terrified of their quotient rule. So what they'll do is they'll say, oh, there's an understood 1 here, so I'm going to move the bottom up to the top. And now we're product rule. This is not much easier. This is not much easier. Okay? I don't think we should do that. Because the easiest way of doing it is you take the derivative of the top, which is 7, you multiply it by the bottom. Now you reverse minus. Now you reverse that game. You take the top, and you multiply by the derivative of the bottom, which is 12x squared. Nothing hard there. And then please don't forget whatever in the bottom, square it. All right. Now, suppose you have a problem like this. Suppose you have this. You need to decide what is the main rule you're going to use. What if you have 7x minus 1 times 3x plus 7 to the 13th power? Now, like always, one way of doing this is to multiply 3x plus 7 by itself 13 times, and then multiply that result by 7x minus 1. But of course, right, most normal people, most mortals, are going to make a mistake in doing that. Very hard to multiply 14 factors. You're going to multiply the 3x plus 7 13 times, and then multiply that by 7x minus 1. Most people are going to make a silly error. I know I would. And more importantly, even if you didn't make an error, it's going to take you a long time to multiply 3x plus 7 13 times. So, we need to use a different technique. And you have to realize that it's this times that. Can we use the rule? The product rule. The rule says first, take the derivative of the first term, first factor, which is 7, and multiply it by the second, which is whatever it happens to be. Plus, now just leave the first, and then multiply that by the derivative of the second. But the second is a function to a power. It's 3x plus 7 to a power. So we use the power rule. We write down the function, the power 13 comes in front, the new power is 1 less. Then do not forget to multiply by that derivative, which is 3. And then, you can say 13 times 3 is 39. So you get 7 times 3x plus 7 to the 13, plus 39 times 7x minus 1 times 3x plus 7 to the 12. Between this term and that term. Terms are separated by addition and subtraction symbols that aren't in brackets. That, I can't argue, that's the plus symbol, but it's in brackets. Just like this one, and that's a minus symbol. Well, the factors are things that are being multiplied, other than in brackets. It's 7 times 3x plus 1 to the 13th. The second term, it's 39 times 7x minus 1 times 3x plus 7. It's 3x plus 7 to the 12th. Well, they both terms have 3x plus 7 factors. The first term has 13 of them. The second one has 12. 12 is the smaller one. They both have 12 in common. They don't both have 13 in common. So I can factor out 3x plus 7 to the 12. And I still have the 7. And I have one more 3x plus 7 to write down. Plus, I have 30. I need 39. I need to multiply by 7x minus 1. I already factored out the 12 3x plus 7s. Okay, let's take this one all the way. 3x plus 7 to the 12th. Inside the brackets, I have 21x plus 49. And then I have 39 times 7 is 273, I think, plus 273x, yes, that seems right, minus 39. And then we combine like terms inside the brackets, and we look to see if we can factor out yet some more. 21x plus 273x is 294x minus 10. Well, they're definitely both even, and 4 does not go in the both. So I can factor out a 2 from here. That goes way in front. This 3x plus 7 to the 12 stays. And after pulling out a 2, I have 147x, 147x, minus 5. And that would be your final answer. Notice that there was one line of algebra, one line of calculus. 1, 2, 3, 4 lines of algebra. And the calculus was very straightforward. All we really did was take the derivative of 7x minus 1, which was 7, and we took the derivative of 3x plus 7, which was 3. The calculus isn't hard. Hard thing is knowing the formulas, knowing the product rule, and algebra. Okay. So sometimes, even when we have a product, we have to use the power rule. Sometimes, when we have a product, we have to use the power rule. The main rule in this last problem was the product rule. But it's embedded in there inside, while using the product rule, that it used the power rule. Now, I'll show you a nice example where you may have a power rule, but that you use the product. For example, if you had 3x minus 1 times 4x squared minus 2x plus 5. And all of this is raised to the third power. The main rule here is the power rule. You have this function to a power. So the derivative is straightforward. Keep that function the same. Keep within those big brackets the same. These big brackets. Play games with the powers. Bring this 3 down, make the new power 1 less. Times the derivative of this. But that's a product. That's a product. So we use the product rule. First, second. It's the derivative of the first, which is 3, times the second. I'm out of space, so I'm coming down here, please. Plus the first factor, which is 3x minus 1, times the derivative of the second, which is 8x, take away 2. There it is. Sometimes when you have a power rule, sometimes when the main rule is the power rule, like this problem is, you have to also use the product rule. Suppose you were given this. Suppose you were told that f of x is equal to 3x minus 1 times 2x plus 3 times 3x plus 5. I guess this isn't a power rule problem, but it's a product rule. But the problem is we're multiplying 3 things. We've never been up against that before. Well, you need to invoke a law that you learned a very, very long time ago, called the associative law. It says that when you're multiplying 3 things, you can multiply the first 2 first, or the last 2 first. So I'll choose to bracket the first 2. So it's like that's the first function times the second function. So the product rule says, so let's write it out in long form. It's the first function, which I'm calling this. The first function, derivative of that, times the second function, 3x plus 5, plus just the first function, 3x minus 1 times 2x plus 3, times the second function, derivative. So now we're doing the product rule. Inside the product rule, look what we have. A product rule. We have to take the derivative of our product. Okay, so it's the derivative of the first times the second, 2x plus 3. Now we reversed again. We keep the first function, 3x minus 1, and we multiply by the derivative of the second function, which is 2. And all of that gets multiplied by 3x plus 5. Plus this, doesn't say to take the derivative or anything of it, 3x minus 1 times 2x plus 3 times the derivative of 3x plus 5, which is 3. There's your calculus. Okay, there it is. Now sometimes when you have a power rule problem, believe it or not, you have to do a quotient. You have to use the quotient rule. For example, if the function j of x happens to be a fraction, 3x to the 4th minus 2x plus 1 over 4x to the 5th minus 11, and this is all to the 10th power. That's the function to a power. What's in the bracket is a function, and it's raised to a power. So, the rule's straightforward. What's in bracket stays there. Play games with the powers. Bring it down, make the new one less. Okay, what's inside the bracket stays there. There it is. Times the derivative of what's in the brackets. The thing is, what's inside the brackets is the quotient. Oh, we'll use the quotient rule. Quotient rule says, here's the top, here's the bottom. Quotient rule says, take the derivative of the top and then multiply it by the bottom. 4x to the 5 minus 11. Minus. Now, reverse that again. Just take the top. 3x to the 4 minus 2x plus 1, and then multiply that by the derivative of the bottom, which is 20x to the 4. And all of that gets divided by the denominator, 4x to the 5th minus 11 squared. Okay, there is 100% of the calculus. And again, other than applying the rule, all we ever did, other than write this and that down in various places, like here and here and there, all we did was take, and here, all we did was take the derivative of the top and the bottom. We took the derivative of the top here, we took the derivative of the bottom here. Every place has an arrow by it, except the bottom. Make that square. Okay, there it is. Sometimes when you use a power rule, you have to use the product rule or the quotient rule. Okay. Now we're going to talk about another rule. Personally, I think this rule is ridiculous 99% of the time. It's called the chain rule. Chain rule. Basically, it says if you have f of x and u is the function of x. Okay, what does it mean that u is a function of x? That is, to know what u equals, you have to know x. In other words, maybe u will equal to x cubed plus 4. To know exactly what this is, you have to know x. So if I just said u equals x cubed plus 4, if you know what this equals, if this equals 20, then u equals 20. Because whatever this is, it says it equals u. Now, to get an exact value for this, you need to know x. If I told you x was 2, 2 cubed is 8, plus 4 is 12. Now I know what u is. But if to get u, you need to know what x is, then we say u is a function of x, u of x. Okay, let me erase a lot of this. But what I just said, that's very important. You need to understand why they say u is a function of x, why f is a function of x. Most people don't understand what u of x means. Well, it means exactly what f of x means. It's just the name of a function. I mean, to know what f is, like if I tell you f of x is equal to 3x plus 1, well, if x is 1, if you know what x is, then you can tell me what f of x is. Because when x is 1, this is 4. So I know f of x, or f of 1 is 4. All right. derivative of f of x is the derivative of y. Remember, another name for f of x is y. The derivative of y with respect to u times the derivative of u with respect to x. And another name for this is dy dx. Now, algebraically, what I'm about to say, in this case, so this is calculus, but you can kind of cheat and say, here, this formula is right because the du's cancel out, and you do get dy dx, exactly what it says it should be. Calculus speaking, you really can't cross that out, but it's a very, very nice check. Okay. This is completely foreign what I'm saying. It's probably actually complicated, but the general power rule will get you out of doing this. Unless your teacher says, find the derivative using the chain rule. So, I tell you that f of x is equal to x plus 4 to the 5th power. And using the chain rule, I want you to find the derivative. So basically, a good habit is, what's being raised to a power you call u. Remember, this is y. So y is equal to u to the 5th. And u is x plus 4. Okay. So now we use this rule right here. The derivative, dy dx, or f prime of x, well, this is equal to dy du times du dx. Now, if I told you y was equal to x to the 5th, well, then the derivative on the right side would be 5x to the 4th. And the derivative of y is dy over d, it's in terms of x, dx. Now, if I told you y is equal to u to the 5th, the right-hand side is 5, the derivative of the right-hand side is 5u to the 4th. The derivative of y is dy over d, it's in terms of u, I write du. Okay. So dy du is the derivative of y with respect to u, which is 5u to the 4th, times du dx. Let's make u a little bit more complicated. It's now x squared plus 4. U is x squared plus 4. So now I want to take the derivative of u in terms of x. That's what this is telling me to do. Find u in terms of x. That is, u equals, and you have x's. Well, that derivative is 2x. Okay, now we just make one substitution for u. Just substitute what u was. U was x squared plus 4. 5 times 2 is 10 times x is 10x times x squared plus 4 to the 4th power. Okay, now just for the record, if you don't have to use the power rule, just a simple derivative. dy dx is equal to a function to a power. Keep the function the same, power comes down, 1 less goes up, times the derivative of this, which is 2x. Well, 5 times 2x is 10x, times the x squared plus 4 to the 4th. Minus some silly error, we should get the same answer, and we did. Notice how little space I needed to do this, and I didn't have to give a long explanation. Let's try this again. Do enough for these becomes a routine. Personally, I would immediately ask my teacher after he or she shows you the chain rule and the product rule and say point blank, are you ever going to ask us on our test to take the derivative using the chain rule? And if they say no, ignore what I say from here on in the last couple of minutes. You never ever have to formally use the chain rule. Okay, I tell you y is equal to 7x cubed plus 4x minus 2x cubed to the 13th power. Call this u. So let u equal 7x cubed plus 4x minus 2x cubed. So instead of this, I want you to see u. So y is equal to u to the 13th. Instead of 1/3, it should be 13. So I'll change that. So y is equal to u to the 13th. Now, y prime, or dy dx, is equal to dy du, dy du times du over dx. Du over dx. You should memorize the formula if you need to. Find y in terms of u and take the derivative. Here's y, it's in terms of u. I won't use this y because it's not in terms of u, it's in terms of x. Y in terms of u, the derivative is 13u squared times the derivative of u in terms of x. U in terms of x. I might need a little bit more space. I take the derivative of u, then I take the derivative of that, because that's u. And I get 21x squared plus 4 minus 6x squared. And then I substitute back what u is, 7x, right here, u, 7x cubed plus 4x minus 2x cubed squared. Okay, sorry about that. The derivative of u to the 13 is 13u to the 12th. So instead of u, I wrote that to the 12th power times this mess. And so there's the answer. A quick check would be if you have their initial problem. And you wouldn't, the only reason you would do it the way I just did it is if you're told to use the chain rule. Okay. So now I'm going to use a power rule. You have a function to a power. You want the derivative. Keep the function the same. Bring down the power. Make the new power 1 less. And then multiply that by the derivative of this. 21x squared plus 4 minus 6x squared. Or minus some silly error. That's exactly what I have here. Okay, it's exactly what I have there. So it's not hard to check it. Use the general power rule. In fact, only do this if you're asked to find the derivative of this. Unless your teacher says you have to use the chain rule. You have to use the chain rule. Well, I would hope that you would get absolutely no credit for doing it any other way. If you're told to use the chain rule and you don't, you get no credit. At least that's how I would grade it. Alright, so suppose I tell you that y, or let's not even use y, g of x. G of x is equal to 7x squared minus 4x over 3x minus 9, and all of this is to the 10th power. Call u the base. So let u equal 7x squared minus 4x over 3x minus 9. what u is. So g is really u to the 10th. But remember, g is really y. So g prime of x, better known as dy dx. Why? Because here's y, and it's in terms of x. dy dx is the same as dy du times du dx. Now, the derivative of y in terms of u. I find y in terms of u. And I take the derivative. Y is equal to something in terms of u. Well, that derivative is 10u to the 9th. Times u, the derivative of u in terms of x. So I find something that says u equal, it has x's. U equals and x's. Take the derivative of that. But that's the quotient. That's the quotient. I use the quotient rule. It's the derivative of the top, 14x minus 4, times the derivative of the bottom, which is 3, minus the top, 7x squared minus 4x, times the derivative of the bottom, which is simply 3. And all of this gets divided by the bottom squared. And there's your derivative. Oh, except you should now go back and plug in what u is. So it's 10 times u to the 9th times what's in here. Not going to rewrite it. The 10, I'll put u in, there's the 9th power, and u is this mess. There's the answer. Okay, now I do want to show you one last problem. Oh, slightly different. This formula that I gave you, it can go on and on and on. You can have dy over any letter, dr. And then dr over any letter, ds. You kind of have the dr canceling, and now you have dy over ds, which doesn't equal that. Times ds, you kind of have the ds canceling over dt. And now you have dy over dt. Multiply by dt over du. Now the dt is kind of cancel. You have dy over du. And now if you multiply by du over dx, now you have dy over dx. So it goes on and on. So suppose I tell you that y is equal to r to the 5th power, and I tell you that r is equal to, so I wrote y in terms of r. I did that right here. Now I'm going to write r in terms of s. So r is equal to 3s squared minus 7. And now s is in terms of t. S, on the other hand, is t cubed minus 4. That's s in terms of t. But t is in terms of u. T is equal to u plus 4 squared. And then finally, u is in terms of x. U is equal to x minus 1. So, dy dx is equal to dy dr, which is 5r to the 4th times dr ds. R in terms of s. Dr ds is simply 6s times ds dt. Derivative of s in terms of t. 3t squared times dt du. T in terms of u is right here. The derivative, well, that's the power rule. Bring power down, make the new power 1 less, which you don't need to put, times the derivative of u plus 4, which is just 1. Just like the derivative of x plus 4 is 1, the derivative of u plus 4 is 1, times du dx, which is, let's make it x squared minus 1, which is 2x. Okay. Now, the thing is, we'd rather not have dy dx in terms of anything but x. It's in terms of r and s, t, and u, and x. So, let's look at 5r to the 4th. Well, I know r can be written that way. So it's 5 times r, which is 3s squared minus 7. But s can be written that way. So it's 5 times 3 times s squared minus 7. 5 times 3 times t cubed minus 4 squared minus 7. But t is u plus 4 squared. U plus 4 squared, so that becomes 6 power. But now u is x squared minus 1. So this becomes 5 times 3 times u is x squared minus 1 plus 4, which is x squared plus 3, to the 6th power minus 4 minus 4 all squared minus 7. That's what goes right here. 5 times 3 times x squared plus 3 to the 6th power minus 4, all of that squared minus 7, times 6s. Can we just keep back substituting? Just substitute back. We now need to know what 6s is. And here's a good example of back substituting. You really need to understand every line I'm doing here. Okay, 6s. Notice, by the way, that what I wrote down in the last line is just in terms of x. I want to write 6s just using x's. Well, that's how I write s. 6 times t cubed minus 4. 6 times t cubed minus 4. But t is u plus 4 squared. So squaring it makes it 6. But u is x squared minus 1. Here, 6 times x squared minus 1 plus 4 is x squared plus 3 to the 6th power minus 4. So it's times 6s, which is 6 times x squared plus 3 20 to the 6th power minus 4. Okay, and then we multiply that by 3t squared. We multiply that by 3t squared. And then just one more. We're almost done. So now we multiply by 3t squared. So 3 times t squared. So t is u plus 4 squared. So it goes to the 4th power. But u plus 4, this adds 4 to both sides. We've been doing a lot of plus 4. Is x squared plus 3. So you have 3 times squared plus 3 to the 4th power. So it's times 3 times x squared plus 3 to the 4th power times 2 times u plus 4. The u plus 4 is x squared plus 3 times 2x. out, you should probably multiply the 5 by the 6, by the 3, by the 2, by the 2, and pull out in front. But other than that, here is the answer. It's only in terms of x. Okay. Want to do one more. It won't be anywhere as long as this. And this last example, and the one I'm about to give you, this might be the only time that you might want to use your chain rule. If I tell you that y is equal to u to the 7th power, and u is x squared plus 3x minus 9. You could say, so y is in terms of u, so we have y in terms of u, but then u is in terms of x. So we have y in terms of x. So we can find the derivative of y in terms of x. And this here is dy du times du dx. The derivative of y with respect to u. So first you want to find something that says y equals and has u's. And there it is. That derivative is simple. It's that times du dx. You want to find something that says u equal and it has x's. U equals, there it is, u equals, and it has x's. Take the derivative of that, which is 2x plus 3. And then you should substitute back what u is. And u is x squared plus 3x takes away 9. There it is. Now, personally, I would have done the problem this way. Y is equal to u to the 7th. That's what I was told. But I was told what u is. Put this right there, right where u is. That is, y is really x squared plus 3x minus 9. I can take the derivative of that, dy in terms of x. Well, you have this function to a power. You want the derivative, bring the power down, make the new power 1 less. Don't forget to multiply by the derivative of that, 2x plus 3. That should be exactly what I have here. Okay, so you don't ever have to use the chain rule. Okay, until you get to trig functions. And even then, you don't even unfortunately, you don't even have to recognize it's the chain rule. Okay, you don't ever really have to use the chain rule. Use the general power rule. Okay, good luck with this. Thank you.